Hey everybody, now that you're familiar with alternative number systems like binary, octal, and hexadecimal, we're going to take a little bit of time here and show that you can perform operations in those number systems as well. Now we're just going to focus on addition and subtraction. Anything beyond that, we can find an app or have a calculator do that. But before we get started with addition and subtraction, I just want to show you something kind of interesting here. On your screen is a hexadecimal multiplication table. Now, for low numbers, we get multiplication products just exactly like you expect. 2 times 3 is 6. Sure, of course it is. 4 times 2 is 8. Exactly what we'd expect. But when you start looking at larger multiplication products, you start getting some strange results. 4 times 4, now that's not 10, that's still 16, but it's the hexadecimal representation of 16. That is to say a 1 in the 16's place and a 0 in the 1's place. 4 times 5 would be 20, right? But 4 times 5 being 20 is a 1 and a 4 in hexadecimal. 1 in the 16's place and a 4 beyond that. 4 times 7 would be 28, but 28 is made up of a 1 in the 16's place and a 12 or C in the 1's place, and so on. And so it looks a little wacky, but we're so used to doing operations in decimal that it's a little bit hard to think about those operations in any other number base. But that's what we're going to do here. So let's start with some addition. Okay, so before we do anything, let's just go back and review how basic addition is carried out. Now, the example on your left, 827 plus 139, I'm just going to specify here that that is base 10 or decimal base. But if we don't see anything else, we would assume that that's the case. So we start way over on the right in the ones place and we add these up. 7 plus 9, that's 16. But this is only base 10. So since it's base 10, that's 16, we're only going to leave the ones down there, and we carry that next digit over, right? Now we kind of take that for granted, but that's going to be important. Then we repeat the process. 1 plus 2 plus 3, that doesn't exceed 10, so we're going to have 6 right there. And then 8 plus 1, that's 9. So the result here is 966, base 10. Now we're going to do the exact same thing in binary, but our base is going to be 2, and that's going to change the look a little bit. Okay. Now, when we were working with decimal, anytime we hit a total of 10, we would carry a digit over. That's going to be true in binary, except every time we hit a total of 2, we're going to have a carry digit. So here we go. Make sure when you do any binary problems, write them neatly. Most of the mistakes I see are from losing columns, especially with binary. It's easy to lose track of where you are. Here we go. 1 plus 1, that is 2. And so we're going to put a 0 down there because there is no digit 2 in binary. But since we've hit 2, we're going to carry a digit over to the next column. 1 plus 0, that's a 1. In our third column in, 1 plus 0 is 1. 0 plus 1, that's a 1. 1 plus 1, there's another 2, but there is no digit 2, so we're going to put a 0, and we'll carry a 1. Now 1 plus 1 plus 1, that's actually 3, right? But that's like a 2 with a 1 left over, so we keep 1, and we carry 1 to the next digit. And our result is 110, 1110, base 2. And we've performed that addition. And let's do one more for good measure here. 1 plus 1 is 2. That means we're going to be left with a 0 there, and we carry a digit over. 1 plus 1 plus 1, that's 3. So here again, we're going to leave the 1 extra and carry the 2 over to the next column. 1 plus 1 plus 1, that's 3 again, so we're going to leave the 1 and carry 1. 1, 0, and 0 is 1. 1 plus 1 is 2, so that's going to be a 0, and we'll carry that 1 digit. That's going to give us another 2, and a carry digit, and a 1. And so the result on that one is 100, 1110, base 2. Okay, and we can adapt that idea to any number base. Let's take a look at an example of octal addition. Now, of course, our digits here are only going to go 0 through 7, the octal digits, and every time we hit 8, we'll have a carry digit. So let's start with our ones place. 7 plus 4, that's 11. But 11 exceeds 8, so we're going to carry 8 over to the next column, and that leaves 3, 11 minus 8, for our ones place. In our middle column, we're going to add 1 plus 2 plus 3, that's 6. And In our next column, we're going to add 6 plus 2. That is 8, but we can't write 8. Our digits only go 0 through 7, so that means we're going to have no 1s and 1 8 left over. And so our sum here is 1063 base 8. Now be careful on these. You're really teaching your brain to think in a different way, which is part of the reason we spend time on this number systems unit. And I just want to note here that if you want to see some more examples of that, just go to YouTube and do a search for octal addition, and you're going to find lots of other examples. I'll give you one for practice in a minute, but let's take a look at some hexadecimal addition. Okay, here we go. We have to remember what the values of the digits are in hex. So just so they're handy, A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15 in our normal decimal system. So here we go. F plus 2, that's really 15 plus 2, or 17. So we've exceeded our base of 16 here, 17. We've exceeded it by 1, and we'll carry that 16 over to the next column. And this is not the tens place, but the 16's place here. Now in this column we have A plus B plus 1. That's the same as 10 plus 11. That's 21 plus 1 is 22. So here again we're exceeding 16, and we're exceeding it by 6. 22 minus 16 leaves us with 6, and we'll carry 16 over to what is the 256's place. And now we add up that column. 1 plus 4 plus 5, that's 10, but we're not going to write 10. We would write A. And so 4BF base 16 plus 5A2 base 16 is A61 base 16. Let's do one more just for a little bit more practice. Okay, here we go. If you need a little cheat sheet with what A through F represent, go ahead and do that. But let's get started. 2 plus 9, that's 11, but 11 base 16 is B. 9 plus E, E is 14, plus 9 is 23. So this total here is 23, but that exceeds our base by 7. So we're going to take away those 16. That leaves us with 7, and we're going to carry that digit over to the next column. Now we have 1 plus B plus 4. That's 1 plus 11 is 12, plus 4 is 16. So we don't have any leftovers, but that value of 16 we're going to carry over to the next column. That's what leaves us with 0. And 1 plus 5 is 6. And so our result here is 607B base 16. Okay, here's one of each for you to practice. Go ahead and perform that binary, octal, and hexadecimal addition. Pause the video, but unpause when you're ready to see if your answers are correct. Okay, here we go. Our first one, we're going to add in binary. 1 plus 1, that's 2. So we're going to have 0 in the 1's place and carry that 2 over. 1 plus 1 plus 1 is 3. That's 2 plus 1. We'll keep the 1 and carry over the 2. 1 plus 1 plus 0 is again 2. There's no digit 2, so we're going to put 0 and carry that 2 over. 1, 0, 0 is 1. There. We caught up. 1 plus 1 is 2. That's a 0. Carry that digit. 1 plus 1 plus 0 is another 2. We'll carry that digit over. 1 and 1 is 2, which is a 0, and carry that digit over. And again we get 2, and we carry that digit over one more time, and there's our result. 1, 0, 0, 0, 0, 1, 0, 1, 0, base 2. Now near the end of the course we're going to see how to use logic to actually perform a binary addition, which is the fundamental basis for any processor. Okay, octal addition. Let's start in our ones place. 3 plus 6, that's 9, but 9 exceeds 8 by 1, so we're going to keep the 1 and carry the other 8. 1 plus 7 is 8, plus 5 is 13. 13 exceeds 8 by 5, and we'll carry the other 8 over. 1 plus 2 plus 0 is 3, nothing to carry there. And 6 plus 3 is again 9, which exceeds 8 by 1. We're going to leave 1 and carry over a 1. And our total is 11351 base 8. Okay, in our hexadecimal addition, F plus 8, that's the same as 15 plus 8, or 23, but that exceeds 16 by 7 and will carry the other 16 over. 1 plus 9 plus 3, that's 13, which is D in hexadecimal. B plus 2, that's 11 plus 2, which is again 13 or D. And in our last column we simply have A, so our total there is ADD7 base 16. Okay, well, of course, if we can add, we can just as easily subtract. So let's take a look at a basic example using plain old base 10. Okay, here we go. So we're going to subtract this time. In our ones place, we have 4 minus 7, but that's not big enough to do that, right? So as you learned so many years ago, you go over to the next place over and you borrow. So that 2 over here is going to become a 1. And what does that add to this ones place? Well, it adds 10, of course. You've always added 10 because you've always worked in base 10. That's not going to be the case for our other work here. So this 4 is no longer a 4. It's 4 plus that 10, or 14, and that's big enough to perform the subtraction. 14 minus 7 is 7. Next column, 1 minus 3, same problem. So we're going to go borrow 1 from the column next to us. And that 1 gets 10 added to it and becomes 11. That is big enough. 11 minus 3 is 8, and 5 minus 3 is 2. And so our difference here in base 10 is 287. And that's all there is to it. Let's do some subtraction in binary. In our ones place, we can subtract 1 minus 0. That's 1, no problem. In our next column, we have 0 minus 1. That 0 is not big enough to subtract, so we're going to go to the column next to us, borrow the 1 that's there, and this gets what added to it? Not 10, but 2. So we actually now have 2 there. 2 minus 1 is 1. Now, of course, we could write the binary representation of 2, which is 1, 0, but I think it's easier to just write 2 since it's the number 2. And here we have 0 minus 1, same problem, and so we can either just count this 1 next to it, or we can borrow it completely, and that changes that 0 to a 2, and 2 minus 1 is 1. And so after subtracting, our result is 1, 1, 1. Now just to verify this, let's take a look at what this arithmetic is in base 10. Our top number there is 1101. That's a 1, no 2's, a 4, and an 8. 8 plus 4 plus 1, that's the same as 13 base 10. And 110, that's no 1's, and a 2 and a 4. 4 and 2 is 6 base 10. So when we subtract 13 minus 6, we should get 7 base 10, and that's exactly what we got for our binary representation. 111 is equal to 7 base 10. So we verified this in decimal. We certainly don't need to, but we can see that it does work out. Okay, let's do one more binary subtraction. Here we go. 1 minus 0, that's 1. 1 minus 1, that's 0. 0 minus 1, we can't do it. We're going to have to borrow. That makes that a 2. 2 minus 1 is 1. 0 minus 0 is 0. 0 minus 1, we can't do that, but there's nothing to borrow from, so we're going to have to go way over here, borrow that 1. This column becomes a 2. But then we immediately borrow from that 2. It drops to a 1 in order to get a 2 in this slot. So we have to borrow from 2 columns over, and then borrow 1 from the next column over to get our subtraction. 2 minus 1 is 1. 1 minus 1 is 0, and there's nothing left in that n column. That leading 0 becomes unimportant then, and our result is 1, 0, 1, 0, 1, base 2. Okay, let's do some octal subtraction. All the same ideas, but we're going to borrow 8 at a time. 6 minus 3, that leaves us with 3 in the ones place. 2 minus 4, not big enough to do that, so we're going to have to go next door, but there's nobody there to borrow. So this 4 over here will become a 3. What does that make this 0 into? How many did we borrow? Well, if that 4 drops to a 3, that doesn't give us 10 here, it gives us 8. But then we're going to borrow one of those 8, it becomes a 7, and that gets us 8 more in this column. So 2 plus the 8 that we're borrowing, that now becomes a 10, and 10 minus 4 is 6. 7 minus 1 is 6. 3 minus 2 is 1, and so our difference there is 1663. Okay, let's do some hexadecimal subtraction. Here again, I've just kind of sketched out our cheat sheet to remember those letter digits in the hex system. Here we go, 2 minus 8, and that 2 is not big enough to subtract 8, so we're going to borrow. That C drops to a B. And what does that gain us here? Remember, that gains us 16. And so what we really have here now is 2 plus that 16. This is the same as 18. 18 minus 8 leaves us with 10. But 10 is represented by A in hex. Our next column, B minus B, that is 0. 7 minus E, that 7's not big enough to subtract E, so we're going to borrow 1 from the column next to it. That drops to C. That 7 will gain 16, and that is now 23. 23 minus E, where E is 14, that leaves us with 9. And C minus 1, that just drops us back to B. B9, 0A is our difference. Okay, if you got those, great job. If not, go ahead and watch those again. But you can also do a YouTube search for octal subtraction or hexadecimal subtraction, and you'll find more examples by many other YouTube posters. Okay, let's wrap up this lesson. There's 3 subtraction problems to do, a binary, an octal, and a hex. Go ahead and perform each of those subtractions and unpause when you want to see if your answers are correct. Okay, here we go. 1 minus 1, that's 0. 0 minus 1, we're going to have to borrow. That'll become a 2. 2 minus 1 is 1. 0 minus 0 is 0. 0 minus 1, we can't do that. We're going to have to borrow again. That's going to become a 0. This will become a 2. 2 minus 1 is 1. 0 minus 1, oh, we can't do that. So we go next door. There's nobody there to borrow. Let's take that 1. This becomes a 2. But that 2 immediately becomes a 1, so that this can become a 2. 2 minus 1 is 1. 1 minus 1 is 0. And there's our result. That leading 0 isn't necessary, so we could also write that as 1, 1, 0, 1, 0, base 2. Hopefully you got that. Let's do our octal subtraction. First column, the ones place. 7 minus 7, that's 0. 3 minus 6, that 3 is not big enough. We're going to go next door and borrow that 4. It becomes a 3. That adds 8 to this, so that that's now an 11. 11 minus 6 is 5. 3 minus 4, not big enough. Let's take that 5 and make it into a 4. This 3 gets 8 added to it. It's now an 11. 11 minus 4 is 7. 4 minus 2 is 2. And our result in octal is 2750. Hopefully you got that one. Rewind if you didn't and spot your mistake. And our last problem of the day here, A27E base 16 minus 2C8 base 16. Here we go. Okay, E actually represents 14 in hex, so 14 minus 8, that leaves us with 6. 7 minus C, that 7 is not big enough. We're going to go next door and borrow 1 from the next column. That 7 gains us 16. This is now a 23. 23 minus C, but C is 12, so 23 minus C, that's 23 minus 12, that's 11, which is B. A lot going on there. 1 minus 2, that's not big enough, so this A is going to become a 9. It drops from 10 to 9. This 1 gets 16 added to it, so it's now 17. 17 minus 2 is 15. That drops back to F, and our 9 is all alone. So 9F B6 base 16, that's our result, and we're done. A lot of borrowing there. You might want to rewatch that example one more time if you didn't get that to work out. Okay, well, actually, hopefully you find that alternative number system arithmetic to be a little bit fun. It really forces your brain to think in a new way, and that's always a good thing. I just wanted to make a note here that you might have a scientific calculator, a Texas Instruments, a Sharp, or a Casio. Most scientific calculators, you can change them into octal or binary or hexadecimal mode and perform the subtraction, addition, and even multiplication and division just like any other calculator, like we would in base 10. If you don't have a scientific calculator handy, you can also download a number of different apps. There's hexadecimal calculator apps and octal calculator apps that will allow you to check your work. And I would encourage you to do that just as you're working through the problems to make sure that they're working out. But make sure that you are able to perform addition and subtraction using these algorithms, because when we get to the unit test, that's how you'll demonstrate your understanding by actually writing out that process. So, okay, great. Go ahead and do the practice problems. As always, let me know if I can help you out. It's tricky stuff. Good stuff, though. We'll see you in the next lesson.